Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
You've probably worked with triangles over your mathematical career, but there is actually a theorem about the angles inside a triangle, and I bet some of you might already know that. But it's called the triangle angle sum theorem. I drew an M instead of an H. All right, so let's say you're given triangle ABC. So given that you have a triangle ABC, the triangle angle sum theorem states that if you have a triangle, then the measure of angle A plus the measure of angle B plus the measure of angle C is going to add up to 180 degrees. Okay? If you have a three-sided shape, then that's going to be true every single time of the angles on the inside. I'm going to give different marks because I don't want you to think they're congruent. Okay? So angle A plus angle B plus angle C is going to be 180 degrees. Again, those are the angles inside the triangle. We'll talk about other types of angles that you can come up with a triangle. So let's give you a pretty complicated little situation here. And we are going to justify anything we can come up with. All right, so boom, 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 boom. All right, so 25 degrees is going to go right there. I'm going to label this y degrees, this x degrees, this 62 degrees, and this 44 degrees. Okay, so what do we know? Well, I didn't label the points, so maybe I should. Nope, I don't want to call them X, Y, Z. A, B, C, D, and E. How about that? I want to find out X and Y. That's my goal here. Well, what can I do? If I just focus in on triangle CDE, then I know that by the triangle angle sum theorem, and I'm going to abbreviate that, triangle angle sum. I know that angle D plus angle E plus DCE, that angle, is going to add to 180 degrees. So that means I should be able to find X right here. Okay, 62 plus 44 is 106. You'll notice I keep writing my degree sign. That's an important thing that you should carry into trigonometry and calculus. So subtract 106 degrees from both sides, and x degrees is going to be 100, or I almost wrote 106. I'm subtracting 106, 74 degrees. So now we know this is 74 degrees. Okay, well, the other triangle, we only have two angles, so I can't do that right now. However, I see that X marks the spot, right? Kind of a joke. I get it. Those are two lines and they create vertical angles. And if you recall from previous videos I've done, we know that vertical angles happen to be the same size. So if it's 74 here, then it's got to be 74 here. And lo and behold, now I can go back and I can use my triangle sum theorem again, because now that I know that this angle is congruent to this angle, I can go, and that's again vertical angles, and do 74 plus 25 plus y gives me 180. And of course those are all degrees. Okay, so that means 99 plus y has to give us 180. So now we know that y is 81 degrees. So all because of the fact that we know triangles add to 180 degrees, and that little bit of vertical angles helped us out of there a bit. All right, so with triangles, we do have some interesting other things that can happen. So you can take your triangle and you can extend the side. Now, when we extend it, I extended that to the right. So then I would have to spin this and extend that to the right, and then spin it again to extend my third side to the right. So you can only go one way. So the rays, right? Once you start it, you don't want your rays to cross too much. So you go from, if this is 1 and this is 2, what do we know about angle 1 and angle 2? And we know angle 1 is an inside. Angle 1 is interior because it's inside the triangle. So therefore angle 2 is exterior because it's outside of the triangle. Okay, so they are interior angles versus exterior angles. If you noticed, angle 1 and angle 2 happen to make a linear pair, right? Which means that they add to 180. You noticed a lot of things in algebra or in geometry are either equal or they add to 180. Let's take a deeper look at those exterior angles versus their interior angles. So I have my triangle, right? Okay, and now I'm going to give us some generic numbers. So we're going to make this one 50, this one 70, and therefore that makes 120. So by our triangle angle sum theorem, that one is 60, so that they add to 180 total. Okay, so looking here at this first one, because we have a linear pair here, we know they add to 180. So 70 plus 110 would be 180. If I look at our pink ray, 60 on the inside, so that would give us 120 on the outside, so that they add to 180. And our green, we have 50 on the interior, so we'd have 130 on our exterior. And I went ahead and I put that, all 6 of those angles written down on there for a reason. So again, these are a linear pair, so they add 180. These are a linear pair, so they add to 180. These are a linear pair, so they add to 180. We know the 3 interior angles add to 180. So what do you notice about the exterior angle? Specifically, I want you to compare an exterior angle okay. I want to look at the exterior angle sum. So in this case, it would be 110, 120, and 130. If you add all that up, you get 360 degrees. So that's a cool fact. Another cool fact is, what do you notice about (110) versus 60 and 50? I notice that 50 degrees plus 60 degrees equals 110. Okay. Well, does that hold true in any of the other locations? Okay. So notice that 110 is touching the 70, meaning it's adjacent, but it's not touching the 60 and the 50. Okay. So 120 is touching the 60, which means it's remote from these two. Does that work? Absolutely it does. 50 is adjacent to 130. And 130, while it's adjacent to 50, is remote from 60 and 70. So what we can tell here is actually another theorem, and it's the exterior angle theorem. Your exterior angle will equal the sum of the remote interior angles. Okay, so in summary, if I call this angle 1, and I call this 2 and angle 3, every single time the measure of angle 2 plus the measure of angle 3 happens to equal the measure of angle 1. So that's a nice little way that we can figure that out. And again, we can do a proof from that. We can use, the triangle angle sum theorem along with supplementary and use substitution, and we absolutely get that. So just keep that in mind that these are provable. So for example, if we wanted to do one, and we said that this is x degrees and this is 49 degrees, how could I find x here? Okay, well, I have two options. I can either find this angle right here and then say these have to add to 180, or I can just say, hey, the remote interiors added together have to equal 104. I can subtract it and get 55. Otherwise, I'm coming over here going, well, that's 104, so this is 76, right? So then I'd have to do 76 plus 49 plus x equals 180, which means, what do these add to? Oh yeah, they add 104. So there's several ways that we can do that, but it is kind of a neat little thing. But the exterior angle sum was just kind of a fun extra. The big thing is knowing that your exterior angle is the sum of your remote interior angles.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.